Before starting our actual session, let me introduce our keynote speaker. Today's session keynote speaker. Uh, it is my privilege to introduce our esteemed keynote speaker for session number 4 of this 3-day faculty development program on additive manufacturing and 3D printing. We are honored to have with us Mr. Pushkar Suryawanshi, a distinguished expert in the field of 3D modeling, product development and training. Sir has completed his bachelor degree in mechanical engineering and hold a postgraduate diploma in additive manufacturing. With 4 years of rich experience, he has contributed significantly to advancing the application of this transformative technology. Today, Mr. Suryavanshi sir will be guiding us on two insignificant topics. First, application of additive manufacturing in mechanical engineering, and second, case studies in automotive, aerospace, and tooling industry. We are eager to gain valuable insight from his expertise. Without further ado, I request Mr. Pushkar Suryavanshi sir to take over this session. Uh,
Thank you so
sir,
much, sir, for this
okay.
introduction. Shall we start?
Yes, sir. Yes, sir.
Okay, so very good afternoon, everyone. My name is Pushkar Suryawanshi. I am co-founder and director of 3D Shikshan Educational Consultancy. So basically, our startup is educational consultancy. We are incubated at COAP's Bhava Institute of Innovation, Entrepreneurship and Leadership. And from last 3 years, we are working with different academical institutions like engineering, pharma, medical, diploma, ITI, and we are helping all these academical institutions to adopt a cutting edge technology like 3D printing. We are an ecosystem builder. We have developed total 23 3D printing laboratories at 23 different educational institutions from Pune, Nasik, and Ahilanagar district. And with this Center of Excellence module, or with these labs, basically we have built a ecosystem which can support all kind of 3D printing requirements of an engineering or pharma institute. And this is how we are helping academia to integrate 3D printing into their curriculum. So, without wasting much more time on my introduction, so I think we let's start with our topic, that is, so basically for the next 2 hours, we need to discuss on two major topics. First one is a application of additive manufacturing in specifically in mechanical engineering, and second one is case studies, which actually plays a major role in order to improve our thinking towards this technology. Means through the case studies we basically getting an idea that how our surrounding industry is utilizing this technology and getting benefit from it. So through case studies we will have a lot of discussion. So before starting with this, I just wanted to mention few points here. So when in 1986, 3D printing, the first 3D printer was developed, and from that day to year 2025, our industry got several 3D printing technologies. And among all these technologies, mostly 5 to 6 technologies, that is FDM, SLA, SLS, material jetting, direct energy deposition. Such a kind of technologies are widely used in India. While talking about India, these are the most favorite 3D printing technology that our industry is using. But why 3D printing got such a type of attention, or what we can say, the credibility? There is a small reason behind that. In our mechanical engineering, in our manufacturing process curriculum, we have gone through several operations like cutting, drilling, boring, chamfering, sheet metal working, bending, drawing, forging, molding and casting. And if we calculate all these processes, the count will be more than 100. So there are plenty of different processes are available. But when we categorize all these processes, then there are only three categories. First category is a subtractive manufacturing. Second category is a formative manufacturing. And third one is a molding and casting. All our lathe machine, CNC machine, VMC machine, drilling machine, cutting, drilling, boring, chamfering, these all comes under subtractive manufacturing. On the other hand, second is a formative manufacturing, sheet metal working, bending, drawing, forging. These are the example of formative manufacturing. And lastly, there are molding and casting. So the combination of subtractive, formative, and molding and casting, combinedly known as a conventional manufacturing or traditional manufacturing, that we humans are using more than 250 years. But when 3D printing comes, 3D printing does not come as a single operation. 3D printing actually brings a new type of manufacturing, that is additive manufacturing, and that is the major reason behind a success of 3D printing in industry area. Because when 3D printing comes, it is not like just an operation that we got a machine and through that we can start to manufacture things. But when 3D printing comes, it actually brings a fourth type of manufacturing process known as a additive manufacturing or rapid prototyping. And that is why, because from the last 250 years, our entire manufacturing processes are dependent on the conventional manufacturing, which includes subtractive manufacturing, formative manufacturing, or molding and casting. Even in our day-to-day life, we are using several things, starting from specs, mobile phones, laptop, tablet, clothes, furniture, vehicles, etc. Each and everything are example of conventional manufacturing. But when 3D printing comes, it actually brings another type known as the additive manufacturing, and that is why the importance of 3D printing is increased nowadays. So, when such a technology comes, it is very important to understand its advantages, its limitation, and applications also. Because unless and until you are aware of these advantages and limitations of any technology, only then you can utilize that technology in an effective way. So, I will give you a small example. In our house, in our bathroom, the common thing we use is a bucket or mug. The material into that is basically ABS type material, acrylonitrile butadiene styrene, which is easily available for the 3D printing purpose also. And if we try to print a bucket with our 3D printer, it will cost us around 300 to 500 rupees, and it will surely require a print time of minimum 15 to 20 hours of time span, even whatever the printer you are using, but still it will take 15 to 20 hours of time span. On the other hand, a similar component we can easily able to buy it from the market for just 50 to 100 rupees. So listen carefully what I'm trying to say. For the user, for any additive manufacturing user, it is very important to understand where to use this technology and where not to use this technology. Because sometimes people are debating on or comparing subtractive manufacturing with additive manufacturing. What my personal opinion is, the advantages or application of both these technologies are different. So it is not convenient or it is not equivalent to compare this technology with each other. Both these technologies has their own advantages and limitations. So in order to use a technology like 3D printing, the user or the operator should have an understanding of advantages, limitation, and the application of this technology, and only then he can use that technology in an effective way. So, starting with the first topic of our discussion, that is application of additive manufacturing in mechanical engineering. So, this is a very long part. We required a 2 to 3 days of time span just to discuss on this point, because in our manufacturing process, in a conventional manufacturing process, there are lots of advantages, but along with that advantages, there are certain list of disadvantages offered by the conventional manufacturing, and in some way 3D printing has a capability to resolve those disadvantages and fix the issue which has occurred. But here we have identified 12 different points or 12 different application that actually matters to the industry, and that is why that is the reason why industry is adopting 3D printers into their uh, working culture. So first one is a rapid prototyping. So the word prototyping is very famous, common, and it is a very mandatory thing while designing or developing any type of product, because it is not possible to get a full-fledged final product in just first attempt. In order to manufacture, or in order to develop any product, mechanism, machine, we should have a multiple prototypes of that. Means firstly our design team will design that part, then manufacturing team will manufacture that thing, then testing team will do a testing on that. Based upon testing report, our design will again change, then again manufacturing, again testing, and we need to do this process again and again for plenty of times. And during this process, so this entire process is known as a prototyping. And when 3D printing comes, this prototyping speed basically increases. That is why 3D printing or additive manufacturing, also known as a rapid prototyping. So additive manufacturing basically allows engineers to quickly produce functional or working prototypes before going for the mass production. It actually help us to reduce the prototyping cost, and it actually help us to reduce the leading time. Means a small example from the PepsiCo company. If PepsiCo wants to launch a new bottle for their cold drinks, then earlier they required a minimum time span of 4 to 6 months in order to send first bottle out of the factory. But when they integrate 3D printing into their system, the leading time totally reduces, and they have successfully sent first cold drink bottle in just 48 hours of time span. This is how 3D printing is actually uh, increasing the speed, or the increasing or promoting the prototyping process. So the first and important use of 3D printing technology should be for the prototyping work, and this is what the important area where industry is getting benefit from it. Here I have also integrated two case studies in order to understand how these companies. So first test case is from the Ford Motor Company. So here Ford is utilizing FDM and stereolithography 3D printing technology for prototyping vehicle components. This actually helps them to reduce their design cycle time around 25 to 45%. So this percent value is increasingly relatively very high, and it actually helping them to save millions of dollars during this process. Along with this, this is a second case study from the NASA. At every aircraft needs to complete one wind tunnel test. Wind tunnel test. There are one test for the aircrafts that need to be completed, known as the wind tunnel test. And here NASA is using a 3D printing technology to fully manufactured, what we can say, fully prototype a model of an aircraft for a wind tunnel test. So instead of going with actual material, they have printed few components of that aircraft, and they did testing on that. So this is how 3D printing industry is helping. Talking about our Pune region, Bharat Forge has their own 3D printing lab. Wipro 3D has their separate additive manufacturing unit. Tata Motors, Mahindra and Mahindra Group, these all companies are nowadays integrating 3D printing in their design cycle process. So this is what the first application of 3D printing. Second and more important is making lightweight objects or optimizing topology of a specific component. So earlier there are plenty of good designers, but they don't have enough manufacturing process or machines that actually converts their design into reality. So earlier there were so many restrictions on that. But when 3D printing comes, it actually provides a design freedom to any designer working in the field of industry. So through 3D printing, nowadays it is very easy to convert your imagination into reality. 3D printing also promotes to manufacture a lightweight part by integrating lattice structure into it, by integrating, or we can say tuning the slicing parameter during the process. So through all this process, it is also very easy to control over the weight of any mechanism or component. Here, let's have a discussion on two examples. First one, a world famous car known as a Bugatti Chiron, which actually runs with a high speed of around 375 km per hour. Bugatti was facing issue with their brake calipers, as the traditional brake calipers and the weight of those brake calipers are relatively high, which actually having a negative impact over their design. So what they did, they use a 3D printing technology. They use the titanium material, and they have printed a fully fledged 3D printed titanium brake calipers, and they have integrated these brake calipers into their vehicles. And now these brake calipers has a 40% less weight than the traditional one. Even the performance is same. So it is not just for the prototyping stage. All the Bugatti Chiron that is running on the highways, all these vehicles has a 3D printed brake calipers made up of a titanium material. And this is what the 3D printing actually is. And this is how 3D printing is providing its benefit to different sectors of an industry. Also see this particular image. Here the similar mechanism have been distinguished in two different geometries. The purpose of both these brackets still same. First one is a regular cast steel bracket, and second one is a 3D printed processed titanium bracket. So what actually 3D printing brings for us? It is not like that ki, earlier people are not able to manufacture the thing like this. No, it is not like that. Earlier people also has a very good understanding of design related things, but earlier there are no such types of machines available that can easily able to convert their complex design into reality. There are multiple restrictions at that time, and considering all these things, 3D printing actually provides a design flexibility, or we can say design freedom, to the design engineers. So this is how 3D printing is helping our industry to just manufacture a lightweight part without what we can say the component having a proper strength weight ratio. So 3D printing actually helping us for that. I will also request all the participant during this session, if any individual has any type of query or doubts, we are totally free to hear your queries, and we are very happy to provide you a resolution for that. So please do not hesitate to, even though during a ongoing session, if anyone has any type of query, we are requesting all those individuals just to unmute yourself, and you can directly start to ask your question. Okay. Third one is a manufacturing of end use part. So mostly what people are generally saying, 3D printing is only capable for the prototyping related stage, or just to what we can say just design iteration, or other kind of things. But nowadays we have that kind of technology that has a potential to manufacture end use or replacement parts. Means nowadays a 3D printed components has enough strength, enough capability to entirely able to replace a traditional component. So this is what the 3D printing is. So here uh, we have integrated two case studies. First one is from GE Aviation's 3D printed fuel nozzle. So see this particular image. This is a product. This is a 3D printed component. Sorry, 3D printed component from GE Aviation's 3D printing fuel nozzle. These nozzles are 5 times more durable than traditional one. So the fuel nozzle that was manufactured through the traditional process, this particular 3D printed fuel nozzle has a 5 times more durability than the traditional one, and also it is 25% lighter than the traditional one. So here we are getting benefit from the two different ends. Firstly, through 3D printing, we are getting a component having improved strength, having a long durability, having a reliability, and even the product is much more lighter weight than previous one. So it is also convenient to replace the traditional components with the 3D printed components for your machine, mechanism, or system. whenever it requires. BMW is also using additive manufacturing technology to produce custom jig and fixtures, and this actually helps them to drop down their production cost by 58%. 58% is not a small figure; it is a very good figure, and this is how the 3D printing is helping different, whether it is automobile industry, food sector, pharma sector, medical sector, mechanical industry, aviation industry, customization, jewelry, everywhere. 3D printing will definitely provide you a solution for your problem. Next is a custom and on-demand spare part manufacturing. So it is actually the MSP of 3D printing. That 3D printing provides a customization. This is the most MVP application or the advantage of 3D printing, as it promotes customization. It is more convenient for the small batch production. So here also 3D printing can easily able to manufacture custom or on-demand spare parts whenever there is such a requirement. Deutsche Bahn, a German railway company that 3D prints spare parts for aging train components and reducing downtime. So this particular company is producing 3D printed spare parts of a railway, or the several components of a German railway, in order to reduce the leading time, in order to reduce the breakdown duration of that particular train. Mercedes-Benz also offers a 3D printed spare parts for the trucks in order to improve their service time and logistics. So nowadays it is not many people, uh, earlier people having their own inventory where they have storing tons of material for the backup or for the, what we can say, for the spares. But after 3D printing technology, industry is getting benefits in order to manage their inventories. So nowadays, their inventory, the area that actually covers the inventory, nowadays reducing quite good. 3D printing is helping them to just, because in, if in the morning if you have design, then till 3 or 4 p.m. your printer will convert your design into reality, and till 6 or 7 p.m. your design was completely tested. So within just 24 hours, 3D printing actually converts from starting from the designing process to the manufacturing to the testing. So this is how industry is getting benefit from it. Another application, tooling and jig for the manufacturing. Additive manufacturing allows a quick or faster production of custom jigs and tools and fixtures, which actually improves the manufacturing efficiency of a specific industry or component. Here, vehicle brands like Volkswagen, aeroplane brands like Boeing are also utilizing 3D printing for their respective work. Volkswagen uses 3D printing technology in order to manufacture jig and fixture, which actually help them to reduce 90% cost and a leading time during this process. So these are the very good figures, and this actually promotes the sustainable manufacturing, where uh, we can easily be able to manufacture different kinds of component which are in a much more lesser cost. Alongside, Boeing is also using 3D printing technology or 3D printed assembly fixtures to help reduce the production error production errors into their aircraft. So here also Boeing is using 3D printed assembly fixtures, which actually helping them to reduce their production errors uh, uh, during manufacturing and particular aircraft. Next, functional metal parts for aerospace. So I'm very happy to share you that the first ever 3D printed semi-cryogenic rocket engine was built in India in the last year by the company named as Agnikul Cosmos, which that startup getting mentorship from the ISRO itself, and that company has successfully manufactured a semi-cryogenic rocket engine that rocket engine has a capability to carry 100 kg of load to the 600 km above the Earth's surface. But why they use 3D printing? Generally, a semi-cryogenic rocket engine has 100 plus different components, and we need to manufacture all these components separately, and then we are going to assemble it. Assembly has their own advantages, but it also brings a few disadvantages alongside. So what they tried, they tried to print that entire cryogenic rocket engine in just a single print, and they got a success. So India at that time, nowadays, several industries making utilizing 3D printing for space related work, but at that time we were the first who ever built a 3D printed cryogenic rocket engine. So the industries like space sector, or what we can say aerospace or aviation, where dependencies, mm, titanium is the most preferable material in this industry, because titanium offers a very good strength weight ratio. The weight of titanium is relatively less than the mechanical or other kind of properties offered by the titanium. So the technology like direct energy deposition or the technology like direct metal laser sintering, using these type of metal additive manufacturing technologies, it is very easy to print a, or it is very easy to work with a material like titanium. So several aviation industries utilizing different metal 3D printers for production of complex aerospace components that were earlier quite difficult to manufacture. Here we have posted two case studies. First case study is from the NASA. So here NASA's 3D printed rocket injector is 30% more efficient than the traditional one. So the rocket injector, the traditional made rocket injector, and on the other hand a 3D printed rocket injector, these 3D printed components offer 30% more efficiency than the traditional one. Second, Boeing's Dreamliner feature. So this is a specific version of a Boeing 787 aeroplane. So see this image. So integrating 3D printed components with a titanium material into this aeroplane helps to reduce $3 million per aircraft. So talking in Indian currency, so it is cost around 25 crore rupees per aeroplane. So when Boeing integrated 3D printing into manufacturing of this Dreamliner 787 aircraft aeroplane, it actually helps them saving $3 million per aircraft. In Indian currency, 3 millions is around 25 to 26 crore. So this is how this industry is getting benefit from the 3D printing, and it also has a very good application in those fields. Next is a hybrid manufacturing. So this is another interesting part where in very rare case we are aligning additive manufacturing with subtractive manufacturing, that is CNC machining. So sometimes the combination of AM manufactured components and CNC machining will definitely help us to get a complex part easily manufactured with a high precision. So eventually, after manufacturing a part through 3D printing for the post-processing related work, or in order to remove unnecessary material from that design, sometimes CNC machining also can be done. Here, DMG Mori uses hybrid CNC and additive manufacturing system to manufacture high precision turbine blades. So here, this particular industry is using 3D printing technology along with CNC machining to manufacture a turbine blade with a high precision and accuracy. Also, Rolls-Royce 3D prints a post-machine jet engine components improve efficiency. So, see these jet engine components. This particular product is 100% 3D printed, and this component has very good efficiency than the traditional version of it. So, it is also a unique idea because additive manufacturing offers us a design flexibility, and CNC machining can offer us or we can utilize CNC machining for the post processing related work for the metal related printing. Next, it is very important part, that is heat exchanger and conformal cooling channel. So in molding and casting industry, the molds having a internal cooling channels. So in order to increase the production rate, in order to decrease the cycle time of a single component, these types of molds has a cooling channels integrated into it. Through these cooling channels, we can say cold water or cold air we can pass from it in order to drop down the temperature of that mold, which actually can help us to reduce the cycle time of that component. But earlier, let me so see the difference carefully. On the left hand side, these are the traditional cooling channels. We can easily able to see these cooling channels are having a straight path. So either vertically straight or horizontally straight. Why? Because we can in a subtractive manufacturing we can only able to pass the tool in a straight direction. Second thing is a conformal cooling channel. So what is a conformal cooling channels? These are not a straight channel. The direction of these channels can be changed according to the shape of the design or according to the mold core surface of this design. So in order to provide such an intricate cooling channels inside this, the only technology can help you is a 3D printing. Other than 3D printing, it is not possible to manufacture complete conformal cooling channels in this. So this is how 3D printing is also helping in molding and casting industry to improve the design of molds, improve the cooling channel system, improve the manufacturing rate of production rate. Also, heat exchange. So additive manufacturing basically helping us or enables intricate cooling channels inside the design. It also helping to manufacture a complex heat exchangers for the injection mold for better thermal management systems. Here, Siemens Energy, which is a well-known industry in India, has a 3D printed heat exchanger components, which actually helping them to achieve heat dissipation uh, by 30%. So integrating 3D printing in the manufacturing of heat exchanger actually helps Siemens to increase efficiency by 30%. Also, for the injection molding tools and 3D printing cooling channels, it actually helps us to reduce the cycle time by 20 to 30%. So, in this particular image, by integrating conformal cooling channels into any mold or cavity or any injection molding process, which actually helps us to reduce a leading time or the what we can say cycle time by 20 to 30%. See this particular product. This is example of conformal cooling channels, and this is how cooling channels actually able to integrated when we manufacture this with 3D printing. So this is one outlet, this inlet, one outlet, and see. Due to this, the cooling of the product inside this cavity, time of the cycle time is reduced around 20 to 30%. So in this field also, there is one industry known as a Castro, which is situated at Kolhapur MIDC. They have their own 3D printing laboratory where they are continuously trying to manufacture different types of molds, having a conformal cooling channels, having heat exchangers. They had a very good facility over there. Next is a composites and multi-material printing. This is one of the most advantage of 3D printing. As 3D printing, in 3D printing technology, we can integrate two or more than that materials in one another to manufacture a specific product. Manufacturing components with the composites will surely help you to get a very good mechanical properties, to achieve a maximum strength, to achieve a durability, reliability, and several other things. Even though in a traditional FDM machines or resin 3D printers, It is very easy to work with the composites as several composites material are easily available in the market. You can easily able to buy them and you can easily able to print it with your 3D printers. Also, another example, everyone I think you are relatively have understanding of stereolithography. So stereolithography, the technology known as stereolithography, uses a specific material known as a UV sensitive resin. So what we can do, a material known as a graphene, which comes in a very fine powder, a nano powders like structure. We can mix that graphene powder with a resin material, and when we print a part through the stereolithography, we can easily able to experience the amount of strength into that particular design or particular component. Also for the FDM, there are multi-extruder printers are available. You can use multiple materials at a time. You can use multiple materials with multiple colors and shade at a time. Here also we have integrated two case studies. First one is a Mark Forged 3D printer carbon fiber reinforced components which actually help. Hence, in general 3D printing or in FDM, we mostly working with PLA, ABS, nylon, PETG, mostly TPU. So the thing is, when we integrate few third-party materials into this, the mechanical properties of these materials will increase more than 5%. So here, what Mark Forge actually did, they integrated a fine material of carbon fiber into the ABS material, that is acrylonitrile and butadiene styrene, which actually helps them to achieve the 5 times strength than the initial one.
आणि सर अरे अरे सीचं बिल भरायचं
So
बरं
what I'm trying to say,
अरे ऑलरेडी लेट झाले परत
working with a
नाही
multi-material
अरे ते मागचं
is
मेल तिथं
very
गेलं
आपण
effective
काय
and easy
का स्वतःच्या
with
सुद्धा
3D
10 मिनिट
printing
टाकून दिलेस का आता तू?
rather than
मागे
times.
आहे तर 1500
अरे
राहू
तू
दे.
वॉइस आहे ना यार
10th
आता थोडी
application
आहे,
is
वाईट नाही नावाला
अरे
आता.
मग तू
reverse engineering and digital twin
काय
creation.
त्रास
So
होतो.
reverse engineering, it is also known as a 3D
हे
scanning.
मला ते आता पहिला आला
There are
नाही.
certain devices known as a 3D scanner that has the ability to scan a real-time
अरे ये
physical
नको हे बंद
products.
होईल
अरे भाई,
When you scan a
त्या बाजूचं,
specific
त्या
design
बाजूचं.
from 360-degree angle, your scanner will surely provide you a full-fledged 3D design of that model. So there is no such a need of measurements. There is no such a need of designing process. 3D scanning or reverse engineering entirely promotes a bypass or a diversion for this process. So here, the interesting case study is the US Army carries a portable 3D printer, a portable metal 3D printer along with them. These metal 3D printers are used to manufacture end use and replace end use or replacement parts or damaged parts of any tank or any vehicle in a war zone. So this is how this portable 3D printer actually works. Means during a war or during any clashes, if any vehicle or any tank has a damage, and if they want to replace specific components, so they have a metal 3D printer that can actually manufacture that component, and after manufacturing that, we can easily able to replace it with old one. Here also General Electric using reverse engineering technology for turbine blades in order to improve its performance. This is how the 3D printing or reverse engineering is basically integrating themselves in order to produce a good amount of particles. And last, that is 11 one, is micro mechanical parts and precision engineering. So, a famous brand name as a Swiss watch manufacturer, the pricing of these watches are relatively high. They are very precise, they are very small, they are very customized, and for that they are using 3D printing technology for manufacturing to manufacture customized watch components with extreme precision. I just wanted to let you know that we also have few 3D printing technology that can even print parts in microns. Means I can easily able to print a building resting on a human hair with such a small precision. We can have a 3D printing technology nowadays. So for the micro or macro scaling level production, 3D printing also can help you to achieve your requirements. So this is what the potential of 3D printers also. There are also medical devices, several medical devices manufacturing companies are there which integrated 3D printing into their system to manufacture intricate surgical tools. These tools have a very good accuracy and they are actually helping with their accuracy during the surgical operations or different medical related things. So what I am trying to say, we have lots of 3D printing technology that can help us to print a macro or micro level printing to the large scale printing like building and bridges. Second important thing is 3D printing is a single technology from Industry 4.0 that has an application to almost all field. It has application in automobile industry, mechanical industry, pharma industry, medical industry, food industry, fashion industry, jewelry, customization, everything. So 3D printing is actually tool that basically promotes our national education policy 2020 because in Pune, I think many of you already heard about the Sanchiti Hospital at Shivaji Nagar. So they are building, that hospital is building their own 3D printing facility at the basement. So in order to manufacture custom plasters or prosthetic body parts, shoe sole, dental implants like thing, and where engineers are working. In pharmacy, there are one futuristic project that nowadays many people are wearing those smart watches. That smart watches will calculate your SpO2, blood oxygen, heart rate. Along with that, that watch will calculate your body temperature also. Means if you have a fever or not. If a person have a fever, that watch will detect it. That watch will communicate with your mobile phone. Your mobile phone contains one application. That application will generate an e-prescription, and based upon that e-prescription, a pharma 3D printed situated at your home will print a fresh tablet exactly with a similar amount which requires your current health condition. China has successfully printed cartilage from which our human hair was built, and now they are trying to print a living cell. If they get succeed, then in future we might not need a donor. We can entirely able to print a new kidney or liver using patient's own living cell. So this is what the potential or the mm, capability of 3D printing. But since our topic is more related to application of 3D printing in mechanical industry, uh, we will move towards our second topic. So, going forward with case studies, I just wanted to know that is there anyone who having a doubt with these applications, or if you want to suggest few points on this, we are totally happy to hear you. Let me show you. Is the screen is visible to everyone? So I just uh, okay. So here, see this. Here I have taken two sample components. One is a ball bearing and second one is a chain. So in a traditional manufacturing, we are integrating these balls after manufacturing inner and outer circuit. And in this structure, the chain, as we all know that how chains are going manufactured. But since 3D printing is a part of additive manufacturing, we can entirely able to print this ball bearing as it is with zero assembly. See this, let me slice it. So you will have a clear understanding how 3D printing is helping our industry by providing us with a four type of manufacturing, that is additive manufacturing. See this entire chain, we can entirely able to print this without any further assembly. because 3D printing can form a interlock of parts. See this interlocking. So such a kind of interlocking is possible in 3D printing field. So these are the major advantage of 3D printing, and with this, industry is solving their own problems. Even Mahindra is doing a secret project. Mahindra has acquired a one village, an undisclosed village, where they are building an additive manufacturing facility, so they can do an research and development which components into from their vehicles or trucks can be replaceable through the additive manufacturing, and they are doing projects on that. Even our Pune airport has one civil related application where one company has printed a tower, a watch tower, which is a 3D printed part at Pune airport also. So this is what the potential of 3D printing is. Is there any queries or question from your end with these applications?
No, sir.
Okay. So finally, we will move towards our second topic, that is case studies. So what is case studies? Uh, in simple way, case studies are the, what we can say, in our surrounding area, the industry around us, and how that industry is utilizing 3D printing field into their respective work, and how these industries getting benefit from it. This is what the case studies are. So here our focus is on three different case studies. First one is automotive, aerospace and tooling industry. So here what we did, we have provided two types of case studies. Firstly, we will have a discussion on Indian companies or Indian case studies that using 3D printing in their field, and also few global case studies that from the Western countries. So first one is a automotive industry. So here the Tata Motors, this case study from the Tata Motors. Here they are 3D printed prototypes of electric vehicles. So let's see the overview of this. Tata Motors using or used 3D printing technology for rapid prototyping of electric vehicle components. This actually helped them to reduce a product development time for Nexon EV and Tiago EV. For these particular models, they have integrated this technology. They have utilized FDM, that is fused depolation modeling, and selective laser sintering, that is SLS, these types of technology for the prototyping related work. By integrating these two 3D printers, actually help them for the following things. First one, it actually helped them to reduce 40% reduction in a prototyping development time. Means earlier, if in order to complete this work, if they need 10 days, by integrating 3D printing in their system, now that work can be done in 6 days with reduction of 40% in a development time. It also allows them for a quick testing for the battery housing, chassis component, and aerodynamic parts. Since 3D printers does not need any type of molds, does not need any type of tools, we can entirely able to print a part by depositing material in a layer by layer manner. So after completion of that part can be tested for different application. Using this technology will relatively help them to achieve a lightweight design in order to improve efficiency and the range of electric vehicles. So this particular case study is from our Tata Motors, and this is how 3D printing actually helping Tata Motors for several different things. Second case study is again Indian case study from the TVS Motors. Here they have a planning to print a 3D printed motorcycle parts. So TVS Motors incorporated additive manufacturing or 3D printing in developing motorcycle components. They are using metal 3D printing technology to manufacture lightweight, durable engine parts. So basically, they have focused on customized exhaust component for the performance to improve bike's performance. So by integrating 3D printing, actually helps TVS for the following things. First, it actually helps them to reduce the manufacturing lead times from weeks to days. Means the leading time in the manufacturing process. Earlier, it was for few months. Integrating 3D printing, that work now can be done in few days without wasting more time. It actually helps them to improve fuel efficiency and the aerodynamics of their bikes. It also helps them to enhance their design flexibility. So earlier, integration of 3D printing actually provides some freedom to the designer to use their maximum skills to improve the aesthetic appearance of any vehicle or any car. So 3D printer is basically providing that. Third case study is from global level. It is the similar case study that we have learned during our application stage. This is from the Bugatti, a special version Bugatti Chiron. So a supercar that can travel with a speed of 300 and 375 km per hour and is in such a high speed vehicle. The brake calipers is all brake calipers are 3D printed with titanium materials. So here Bugatti partnered with Fronon IAPT, this particular industry, to 3D print world's first ever titanium brake calipers. They have used selective laser melting, that is SLM technology, for proper strength and precision. Integrating 3D printed titanium brake calipers into their vehicle basically helps them to reduce 40% weight reduction compared to the traditional aluminum calipers. Means when they manufacture the similar type of caliper with the aluminum material, and on the other hand they have 3D printed type caliper, there was 40% weight reduction compared to the traditional. Printing it with 3D printing actually helps them to improve heat dissipation and also in enhanced a braking system. These brakes they have tested it on over speed over 375 km per hour. So everything was fine. So I think as per my knowledge there are 100 or 150 Bugatti Chiron running on the roads, and all these vehicles has a 3D printed uh, brake calipers. This is again a global level case study from the Ford. So here they are using 3D printed parts for their vehicle model known as a Mustang Shelby GT500. Here Ford is using 3D printing for manufacturing lightweight components for the Mustang Shelby GT500. Printed intake manifolds, structural brackets, and suspension components are to be manufactured with 3D printing, and they are using selective laser sintering and direct metal laser sintering 3D printing technology to complete this performance. Integrating 3D printing technology into manufacturing of Mustang Shelby GT500, which eventually help them to minimize the weight up to 25%. So it is a very large number. A reduction of weight by the 25% will relatively improve the fuel efficiency of that vehicle as the vehicle's own weight has been minimized. So the overall efficiency or overall performance of that vehicle will surely improve. Faster customization for high performance sports car, and it actually reduced their manufacturing cost by 50%. So this 50% is very big number. In future, in order to maintain the 13 sustainable development goals written by or organized by the US government, 3D printing technology will surely play a major role for the sustainable manufacturing or sustainable development. Aerospace industry. So again, ISRO, it is an Indian case study from our own ISRO, Indian Space Research Organization. Here, in their satellite, they have used plenty of 3D printed components. So here, Indian Space Research Organization (ISRO) develop a 3D printed satellite bracket and thrusters. So see this component, which is situated at this position on the satellite. and this particular bracket or the mechanism is entirely 3D printed. These components are from Chandrayaan 3 PSLV mission. In order to manufacture this component, they have used laser powder bed fusion (LPBF) 3D printing technology. Utilizing this 3D printing technology in a manufacturing of components of a satellite, it eventually helped them to minimize the weight up to 50%. It also minimized the manufacturing time.
सोनं त्याच्यामुळे
Manufacturing time
घेतलं का
cut down from months to
ते
days.
ठेवलं का ते
Means
नाही
in order to manufacture that part with a traditional way requires a several time span of several months. Integrating 3D printing into it relatively minimize the production time or the manufacturing.
अरे
So this is how ISRO is utilizing 3D printing. Actually, ISRO has a special type of 3D printer known as a DED, direct energy deposition, which is very rare in India. It is very difficult to just find and see how direct energy deposition technology work. But ISRO actually has that printer.
काय म्हणतो तू फिलिंग
Sorry. Next case study is again our Hindustan Aeronautical Limited having a collaboration with Wipro 3D in order to manufacture metal 3D printed aircraft engine. So, along with DRDO, with Wipro 3D and Hindustan Aeronautical Limited, they are jointly working on a project where they are trying to create a metal 3D printed aircraft engine components. So Hindustan Aeronautics Limited, that is HAL, used 3D printing technology for fighter jet engine parts. They have successfully printed fuel nozzle, turbine blades, and heat exchanger for Tejas aircrafts. Integrating 3D printing in this field basically increase the efficiency and the durability of that component than the traditional one. It lowers the production cost, reduces the maintenance expenses of that particular machine or mechanism. Integrating 3D printed in this field relatively faster improves the prototyping development and testing speed of that process. So these three organizations working with each other in order to complete this project. Second, this is a global case study from the GE Aviation, a 3D printed jet engine nozzle components. GE Aviation develops a 3D printed fuel nozzle for its LEAP jet engine, and they have used a direct metal laser sintering 3D printing technology for this. What impact actually does by the 3D printing technology is 3D printing replaced 20 separate parts with a single 3D printer component. This is what I'm trying to say. 3D printing basically help us to minimize the assembly related work. Here they have achieved to merge all 20 separate parts to one another, and they successfully printed it as a single component. The overall weight of this product is 20% lighter than the traditional method. Also, the durability or the strength of this entire mechanism is 5 times more than the traditional one. So this particular component is used in over 35,000 commercial aircraft globally. So earlier many people were thinking that 3D printing is also for the prototyping related things, or just to what we can say in order to explain your concept by converting your design into reality. But it is not limited to that stage only. Nowadays we have plenty of different technologies that have capability to manufacture a full-fledged final products
बोल ना
that can relatively match the traditional manufacturing process, or even what I can say more improved durability or strength offer than the traditional manufacturing processes. Next is another case study from the NASA, a 3D printed rocket engine parts. So NASA has developed 3D printed rocket engine components for the Artemis and Mars mission. So they have used selective laser melting, that is SLM, for the thrusters, combustion chamber, and valves. So basically three components, that is thrusters, second one is the combustion chamber, and third one is a valve. They have made it through selective laser melting, that is SLM. Integrating 3D printing into their manufacturing system improves faster production, also reduces the cost by 70%, 70. Also improved the structural integrity under extreme condition. It is also enabled a rapid prototyping for future space missions. So this is how NASA is utilizing 3D printing into their field. And last one is a tooling industry. So for that, I have integrated Indian case studies from the Mahindra and Mahindra Group. Here, Mahindra and Mahindra Group adopted 3D printing to produce assembly line jigs and fixtures for Scorpio and XUV 700 SUVs. Here, the jig and fixtures used are made up by the 3D printing technology known as a FDM, that is fused deposition modeling, and SLM, that is stereolithography for cost effective production. So what kind of impact it actually we can see on the production, that integrating 3D printing
कोणी केलं होतं?
relatively reduced 90% cost in tool manufacturing, tool and manufacturing. Faster fixtures development, the leading time, earlier it was 4 weeks, integrating 3D printing technology, now it is a 4 days. Improved worker efficiency with ergonomic 3D printed tools. So for the workers, we are providing 3D printed jig and fixtures and supportive tools, which actually improves their efficiency, improves their what we can say workers' efficiency towards that particular task. And also, Bajaj Auto 3D printed molds and tooling components. Bajaj Auto also using 3D printing in order to manufacture molds, in order to manufacture jigs and motorcycle assembly lines. They have implemented or integrated resin 3D printers as well as direct metal laser sintering 3D printers for durable and high precision tooling. They also achieve 70% reduction in the leading time by integrating 3D printing into it. Reduce scrap material, which promotes making products more sustainable. Enhance customization for new bike models. So designers also got a design flexibility to try out new designs or new prototypings towards the improvement of aesthetic appearance of a bike. And last one is global case study with tooling industry, that 3D printed manufacturing jigs and fixtures. Volkswagen, a German brand, implemented 3D printing technology for customized tools and fixtures in their German manufacturing plants. They are using Mark Forge carbon fiber 3D printers for strength and durability. Mark Forge is a very well-known 3D printer manufacturing brand with Ultimaker, MakerBot, and they have acquired much more larger stage 3D printers market by providing 3D printers with a proper efficiency. Next, impact. Usage of 3D printed manufacturing jig and fixtures actually helps them to save up to $150,000 annually on a tooling cost. Second, it improves their assembly line precision, which eventually reduces the errors during the process. Also, it improves the faster production cycle, boosting overall efficiency. So, this is how the application of 3D printing has almost at every sector. As a user, it is our responsibility to understand the nature of 3D printers, how it actually works, how to use that 3D printer, what kind of problems can be solved by the 3D printers, these topics are also that much as important because the issue with our Indian 3D printing field is most of the people thinks that this technology is emerging technology, this technology is new technology, but this statement is 100% wrong. In 1981, Japanese scientist Dr. Hideo Kodama firstly appears with an idea that with idea of 3D printing. Then in 1986, Charles Chuck manufactured first ever 3D printer, which is a stereolithography. Then 88 selective laser sintering, 92 fused deposition modeling. In year 2000, we got material jetting. So the thing is, the Western culture is much more ahead of us. Currently, our India or our Asia region is at application stage. Means we are at a stage where we are buying the 3D printers, we are just printing the components, that's it. But for the Western region, they are working or they are utilizing this technology at another level. Means there is one company known as a Stratasys. If we call that company and I simply ask them that I want a printer that can manufacture shoes, they will simply say yes, we will start to manufacture that. Means nowadays companies are working at that stage, and in order to achieve their level, it is also very important that we should tell students about advantages and limitations of 3D printing, and with that knowledge students will have a clear idea where to integrate or where to use 3D printing technology, and then the utilization or the technology will be the knowledge of this technology will be delivered effectively. So that's it. This is about session number 4. This is again a theoretical part, so I have tried my best to cover a maximum points. But again, talking about the application, it is a very long part. There are several sectors where 3D printing is day by day solving the problems. Day by day, we are improving that technology. 3 4 years back, the FDM printers were working at a speed of 60 mm per second. Nowadays, we have a printers that can work with a 2000 mm per second. So improvement is going on. Lots of researchers and people are doing work on 3D printing, trying to improve its efficiency, its time, reduce print time, which is a major disadvantage of 3D printer. But surely 3D printing, because it is a part of fourth industrial revolution. It is a part of a digital manufacturing. So each and every manufacturing sector, we will surely see the development of 3D printing, and the engineering graduate students from this era should know about 3D printing for their survival point of view. Yes, thank you so much. Now we have a question answer session. If anyone from you has any type of query, we are totally happy to resolve your doubts. So we are now open to questions.
Any participant having any query, question, please ask.
Can I question?
Yes.
Which is the fastest printer about 1000
Okay.
mm per second?
Okay. So first one company is divided by zero. So they are offering one machine known as a divided. Actually, I'm not able to recall the exact name of that, but MK3 divided by zero, MK3 kind of one model that actually offers a 2000 per second sprint per second for the FDM 3D printers, as well as Joseph Prusa, a well-known brand from the Western region. Prusa 3D printers also have few variants that can offer us FDM 3D printers with work with a speed of 1000 that is 1 meter per second.
Okay, thank you.
Yeah.
Any other participant having any queries, question?
Hello. So the machine name as divided by zero launches Aeon 500 MK3, world's fastest 3D printer that actually works with more than 1000 per second. Yes, Ion 500 MK3. In order to answer your question,
Sir, when we print a medical device, so which filament or material do you suggest for the medical device?
uh, which kind of medical device means it is a measurement device or for the surgical equipments? Is it going to directly? Is it contact with
Surgical.
the surgical?
Yeah.
Surgical for surgical cobalt, chrome, titanium, or sometimes you can use ceramicals.
No, in polymers.
In polymers, so basically this is not feasible to work with the polymers, but mostly as per my understanding PETG will be suitable because PETG is a material, polyethylene tetrafethylate glycol, which does not show any chemical reactivity with third party materials. So I think we should test it. I'm not 100% sure for that because mostly for the surgery related things, uh, that kind of material is used. So we might have a chance to work with the PETG because the specification of PETG that this material is not easily got chemically reacted to the third party materials. So yes, uh, we can use that.
Okay, sir. Thank you.
Yes, thank you so much.
Anyone? Shall we conclude, sir?
Yes,
Okay.
thank you so
Uh,
much.
Last part, that is a vote of thanks. On behalf of Sir Dr. M.S. Gosai Polytechnic and Mechanical Department, I extend my heartfelt gratitude to Mr. Pushkar Suryawanshi sir for valuable insight on today's session. Thank you, sir. Thanks.
Thank you so much.
Okay.